All right, well, it's good to be back. It's good to be back with you. Reminder, we've got our website up there, creationresearch.net, which is our main international website, and Creation Research UK is the place to go if you want to find out more about the local things that are happening. We're doing a bit of a revamp on our websites and social media and so on and so forth. We have daily content that goes out on our YouTube channel, so do check that out, including a live 24/7 broadcast that goes out around the clock, so you can tune into that anytime that you like. Now, a big part of what we do at Creation Research is the Museums Project, and we've been slowly expanding the Museums Project over the last couple of years. Our main one in Oswestry is now fully open. That includes all of the upstairs. It's only just been the downstairs for a little while, but all the upstairs is open now, and you can come and see all the evidence for yourself. We start with Charles Lyell and Charles Darwin. Charles Lyell promoted the idea of millions of years. We'll talk more about him later. Charles Darwin was Charles Lyell's most faithful disciple. He took the works of Charles Lyell and applied it to the world, which is really how he ended up writing his book on the origin of species. And so one of the things that we try and do is challenge both sides of these men, or both ways of thinking with these men. Charles Lyell is what we're going to mostly focus on tonight, which is evidence of a global flood and so on and so forth. But just very briefly, we do have this display in the museum called After Their Kind. Now, after their kind is a biblical phrase. It's used 10 times in Genesis chapter 1, all in reference as to either how God made living creatures or what he commanded them to do after he'd made them, either to create them after their kind or according to their kind in some translations, or commanded them to reproduce after their kind or according to their kind. Case in point, all of these fossils, and in fact we've got some of them on display here tonight, are all creatures that do not show any evidence of evolution, such as this Jurassic fossil squid. And I'm sure I've used this example before, but it's a very good one. You see, the word Jurassic, don't get put off by that. It simply means named after the rocks in the Jura Mountains, which are in Germany. It was Alexander von Humboldt that gave them that name, and it's got nothing to do with millions of years, nothing to do with evolution, everything to do with where they were first studied. But even if you didn't know that, or you didn't have that label there, you'd probably be able to work out that that was some kind of a fossil squid, for one simple reason: it still looks like a squid. So it doesn't matter if you want to read the rocks as a history of life on Earth, because if you do, you would argue that these rocks with this fossil squid in is some 159 million years old. Now, I don't believe it's that age, but if you want to argue that based on the way that you view the rocks, all you can prove is that in 159 million years, squid have turned into squid. Well, there's certainly no evidence of evolution there. Of course, some people have come up to us and said, oh, well, all that proves is that creatures haven't evolved. The dating methods, however, prove that they must be millions of years old. Well, we decided to have a little add-on to our After Their Kind display, and it used an example of one of these rocks here. You can see the rock here. It doesn't look like much. It's a small sort of knobbly looking rock. Well, it's actually quite fascinating because this rock here has got 3 different dates given to it. The first date is given to it using a dating method called potassium to argon. So something very radioactive decays into something very stable. That's your basic physics. And if you assume the amounts that it started off with, you assume that the rate has been constant, and you assume that nothing outside of it has affected it, then you theoretically can calculate the age of this rock. Now, if you use potassium to argon dating, it says that this rock is at least 1 billion years old, anywhere up to 3.3 billion years old. Now, that's a very, very old rock. That's also a very huge variable in there, right? 1 billion to 3.3 billion. But, you know, if you use helium dating, it says that this rock is not 3.3 billion years old. In fact, helium dating says that this rock is not even 1 billion years old. Helium dating says that this rock is only 620 million years old. Now, that's still a very old rock, but it's nowhere near as old as 1 billion or 3.3 billion. There's one final date for this rock, and that's based off of the eyewitnesses who watched it come out of the volcano. Because this comes from Hawaii. It's from the Kapelehu Hawaii flow, which was observed to have erupted in 1801. In other words, we have an eyewitness account, a number of eyewitness accounts, that tell you that this rock from the lava flow was formed in 1801, and, well, that's got to be your most accurate date. People actually watched it come out of the volcano. And it tells you a couple of things. Number one, it tells you that perhaps the world is not billions of years old. Number two, it tells you maybe the radiometric dating methods are not as accurate as they're purported to be. And indeed, a big problem with them is just the sheer number of assumptions that go into it. And number three, eyewitness accounts are always the best. So thank goodness we have an eyewitness account, not just by somebody who made the world, or was there at the time that the world was made, but actually by the one who made the world, Jesus Christ. So yes, lots of great fossils in the museum, lots of great examples, things that help teach people that you can trust the Bible from the very beginning, Psalm 119 verse 160, and it is a research museum as well. We love to get young people involved and help actually do some of the research, gluing bones back together, mounting fossils up on the wall, and maybe even just using themselves as a measuring stick to show them how big the dinosaur bones are. But you see, all of this museum project, and we're developing one here in Wales as well over the next sort of 12 months, all of them are to teach people this, that all things were made by Jesus Christ. And I hope you realise that in both the Old and the New Testament, it's Jesus Christ who's given the credit as creator, and perhaps most bluntly in Colossians 1:16, where it says not only were all things made by Jesus Christ, they were made for Jesus Christ, and it's in Jesus Christ that everything is held together. So you can find out more about the museum project at creationresearchcentre.com. You can support the UK Museum Ministry that's happening around the country, and you can sign up to our UK newsletter, which is free to do so as well. All right, who am I? What have I been doing the last little while? Because it's been a number of months since I was last here at this church. Well, one of the most exciting things that we've been doing has been to do with my doctorate in paleobiochemistry. Big long word. There's your little definition there. Analysis of original biomaterials in ancient and fossil bone. If you want it really simple, it's looking for soft squidgy stuff in bones that are supposedly far older than soft squidgy stuff can actually survive for. And in particular, we've been studying in the last year this one Jurassic crocodilian vertebra. Jurassic, remember, named after the rocks in the Jura Mountains. This comes from a place called Orton Pit near Peterborough. It's supposed to be some 165 to 170 million years old. Now, that's a pretty old bone. And there's a common misnomer out there. The misnomer is that fossil bones are bones that have turned to stone. And that's not always the case. Have a look at some of these pictures. These are high resolution, very zoomed up, high magnification pictures of that very bone. And what you're looking at is a mixture of bone and minerals. Because these bones are not petrified, which is the true definition of turning to stone. These bones are permineralized, literally meaning permeated with minerals. One red arrow pointing to minerals. You see, the bone is very porous. And so when the bone gets buried into the right conditions, the bone begins to become infilled with those minerals. But the actual bone is still there. The bone, which is even the densest part of the bone, is very, very porous. And so it absorbs those minerals, traps those minerals, preserves that bone trapped in rock, but not necessarily turned to rock. So there's the red arrow pointing to the minerals. The yellow arrow is pointing to the actual bone itself. There again on the right-hand side of the screen, you can even see all the little grains of minerals, tiny, tiny microscopic grains, but there's your grains of minerals that have permeated the bone. There's the actual bone itself. Well, what can we do with this bone? Bearing in mind this bone is supposed to be some 165 million years old. Well, first of all, you can take a thin slice of it. And if you take a thin slice of it and put it under a technique known as X-pol, which is basically cross-polarized lighting underneath a special stain, what you get is, if anything is biological in there, particularly collagen, which is a biological material, it will fluoresce a lovely blue colour. Well, there is, and by the way, this is hot off the press, this is only 8 days old, this data, from a group of us who were working in the USA. Can you see all the blue sort of patches in there? You see, this is all the collagen that's existent in this bone fluorescing. Now, collagen is soft, squidgy material. It's biological material. It's organic material. It's something that has got a known shelf life, something that really couldn't last for millions of years. And yet this is a bone that's millions of years old, and it's full of this collagen stuff. Oh, it's not just one technique, by the way. There's a load of squiggles on a screen. And this has everything to do with something called mass spectrometry, where we take the bone, we demineralize it, so we get rid of the mineral, we then digest the bone, so we're left with a little solution, and if there's anything organic in that bone, it'll be left in that solution. You run it through a special machine that analyzes the masses of things, and it matches, by the way, with collagen. We've actually got several different types here with our modern controls at the top, modern day bovine collagen, which is your sort of lab standard, modern day turkey bone, and then 2 fossil bones. Yes, all these bones that we've tested are full of collagen according to both XPOL and according to mass spectrometry. So let's go one step further. A load of lines on a screen. In fact, there's 2 different coloured lines. Well, it's a little bit sciencey now, but basically if you measure the distances between these 2 different coloured lines, you get a number or a letter. That number or letter results or corresponds to a peptide. A peptide is a special part of the collagen. In other words, we're sequencing the collagen. We're actually reading it. It's not quite DNA, but we're getting awfully close. Well, don't worry if you don't quite get the science, but the point is very important. You see, there were 3 different peptides which were identified from this crocodilian bone, bearing in mind this is a fossil bone, bearing in mind this is a Jurassic bone, supposedly 165 million years old, and this fossil bone actually has 3 peptides in it that match with modern-day crocodilians. The American alligator, the Chinese alligator, and the saltwater crocodile. Now that tells you a number of things. First and foremost, it tells you crocodiles haven't evolved. That even their DNA, even their biology, even their biochemistry is still the same. And the fossils are now proving this. Nearly 200 million years, and there's been no evolution. It also, by the way, tells you that given our modern day understanding in science, and yes, there are lots of critics who will happily tell you this in the biological sciences, the current thinking for the length of time that something like collagen can survive is a maximum of 1 million years. In fact, the official quote from Buckley, who's from Manchester University, says that there is less than 1% chance of less than 1% collagen remaining in less than 1 million years. Now, the letters are there to sort of cover his back, but the point is very simple. By the time you've hit 1 million years, there should be no more collagen left whatsoever. That's what all of modern-day biology tells us. And yet here is a crocodile bone, some 160 million years old, and it's full of collagen, and it's so well preserved we can even sequence the thing. So it really is good evidence that these bones are not millions of years at all. Well, I'd appreciate your prayer as we begin to wrap this project up and finish it up, and we've got a great team on board now working on this project, papers that are coming out very soon, so do continue to keep us in prayer because this is really, really vital research. By the way, we're going to try and get to the bottom tonight of this question of Noah's flood. What evidence is there for it? What evidence in the geological world, what evidence even in the Bible is there for a global flood? Well, if we're going to get to the bottom of it, we need to start with a Bible verse. Philippians chapter 2, verse 5. Let this mind be in you that is also in Christ Jesus. Now, in the context, Paul is dealing with, be nice to one another. Treat your brothers treat your brothers and sisters in Christ, rather, as if you were brothers and sisters. But it's a really good sort of principle to take away. If we're going to get to the bottom of big questions like this, we need to be thinking about the world the way that Jesus Christ thinks about the world. So let's get a biblical perspective. In the beginning, God created. Genesis chapter 1. That, by the way, already puts you at odds with all forms of secular atheistic science that tells you we evolved out of the slime. By the way, God also created the world very good. And you and I tend to view the word good as a moral word, and it is, but it's more than that because God actually described what his very good creation was like. Genesis chapter 1, verse 29 and 30, the animals only ate plants. So there was no killing, there was no death in the beginning. It was a very good world. Genesis chapter 2, Adam and Eve are in the garden. They have no clothes on, but they're not getting cancer from the sun, and they're not freezing to death at night. So the climate was very good. By the time we get to Genesis chapter 3, man has sinned, God curses the ground, death enters the world, and the world changes from good to bad. And by the time we get down to Noah's flood, we're told that the thoughts and the intents of man's heart is only evil continually. So Genesis chapter 6, I will bring a flood to destroy all living things under heaven that has the breath of life, says God. Genesis chapter 7, it comes to pass, and only Noah and those on the ark survived. See, by the time you get to Noah's flood, the world had changed from good to bad to worse. So the Bible talks about a great big flood, and many people have this question: just how big was it? Well, according to the Bible, it does give us the answer. Genesis chapter 7, verse 19. The waters prevailed exceedingly upon the earth, and all the high hills that were under the whole of heaven were covered. See, the Bible describes the global flood in Noah's day as being just that, a global flood, something that covered the whole of the earth. And one might ask the question, well, if this really is the case, if there really was a global flood, what kind of evidence would we expect to find? Well, we're going to start close to home. We're going to start with some evidence in the United Kingdom. We can't just stay in the United Kingdom because, well, of course, we wouldn't ever find evidence of a global flood because the globe is a lot bigger than the United Kingdom. So we're going to sort of expand out as we go. But we need to lay down some principles first. There's the United Kingdom. We're going to go down to the south coast, to a famous stretch of the coast called the Jurassic Coast. And every couple of years we hold a big convention where for 5 days we go down on the beach and dig up fossils. And we have speakers and seminars in the evening. Well, this was back in 2022. Answers in Genesis were involved. And we got to go out on the beach every day and dig up fossils. By the way, little spoiler alert, we're looking for, probably not next year, but the following year, to actually hold one in South Wales. So keep an eye out for that and ask me more details afterwards. But we go out on the beach every single day and we learn how to dig up fossils and we learn how to get hands-on with the rocks. I mean, God is the God of the real world, and so getting out there and getting your hands dirty in God's real world is a really good way of finding out more about Him. You see, the Bible says that if we don't praise God, then even the rocks will cry out. And we like to think that they cry out His praises anyway, both as creator and as judge. Speaking of Him as judge, here is Dr. Diane Eager. And Dr. Diane Eager is looking very pleased with herself because she's found a fossil. Specifically, you see the long brown thing? It's fossil timber. It's fossil wood. And it's so well preserved, we even know what kind of tree it comes from. It comes from the Araucaria group of trees or the monkey puzzle trees, the southern conifers. Now, you know what a monkey puzzle tree is, and you know what a southern conifer is because they're still alive today. So what evidence do we have? After their kind. They haven't actually evolved. But there's evidence of God as judge here because, you see, she's pointing out another fossil as well. It's one of those curly-whirly ammonites. Now, ammonites are a deep-sea creature. Trees are land plants. And so if you ever find deep-sea creatures and land plants buried together, you have very good evidence of a flood. Something that has brought the two things and buried them together where they would not normally be found together. So yet the evidence really is true. You can find the evidence of a large flood down in somewhere like Dorset. And you can indeed trace the Jurassic rocks all the way throughout the UK. It's not just the plants, by the way, it's the dinosaurs as well. Here is Scelidosaurus. Scelidosaurus is one of the dinosaurs that has been found down at the Jurassic Coast. There's the artist's impression. There's what the actual fossil looks like. Now, they don't like you taking photos of this fossil in the museum where it's currently displayed, so we had to go and get the original owner to get his permission to point out one rather fascinating thing about this fossil. I mean, for starters, you can tell that the thing has drowned just because of the shape that it's in. His head is thrown back, tail's in the air, but there's the owner pointing out something rather fascinating about this dinosaur. You see, if you get up close to the throat of this dinosaur, it's actually got food still in its throat. Now, you can tell whether food in the throat is on its way down or back up based on how digested it is. And true enough, if you follow that food and trace it all the way down into the stomach, there is still food down in his stomach. You see, this is a vomiting dinosaur. A dinosaur that's been caught up so suddenly and so violently, the food content has been forced up its throat. Yeah, it's got food in its stomach, vomit in its throat, it is squashed, and it's buried with seashells. Deep sea seashells. There's no doubt about it, this is a creature that has drowned. And it's a creature that has drowned in a flood because you have land creatures plus seashells plus plants all buried together, which all equals a flood. By the way, if you want to find out more evidence like this, you can either come on a field trip. We lead field trips all around the globe, but particularly here in the UK. And we've produced a series called The Rocks Cry Out, so you can visit these kinds of locations and do the research for yourself. See the evidence for yourself. We've got the details on the one in Charmouth and Blackven. There's one in Wales. And, well, somebody mentioned this earlier, Tights, Mites and Fossil Fights. It's sort of the last 10 to 15 years worth of research, all collated together, all looking at evidence that the world is not only young, but that Noah's flood was truly real. You see, all of this brings us to this point. When you come to the point of fossilization, when you're dealing with how fossils are made, it's got nothing to do with time, but everything to do with a process. You see, the secular scientists will say, well, give it enough time, anything can fossilize. Now, time is your biggest enemy when it comes to fossils, because if you allow too much time to fossilize your creature will be destroyed long before it has chance to actually become a fossil. It's got nothing to do with time, it's got everything to do with getting the right process, but the big question is, what process are we talking about? Are we talking about a textbook process? Because you see, one of the textbook processes that is supposed to take millions of years is the formation of limestone and chalk. Well, let's have a look at that. Let's take you, again, a fairly local, as in the same country, let's take you to Hunstanton, over on the North Norfolk coast. I grew up not too far away from there, and I spent many a happy day down on the beach. And while all my siblings were splashing in the sea and paddling in the rock pools, I was in the cliffs looking for fossils. You see, it's a fascinating place. You've got 3 different coloured rocks there. You've got the brown rock on the bottom, you've got the red rock in the middle, and you've got the white rock at the top. There's your technical names. The bottom is a type of sandstone called carstone. The middle is so unique to the area, it's only found in one other place in the world, it's actually been called the Hunstanton Formation. It's a type of red chalk. Chalk like your White Cliffs of Dover chalk, but this is full of iron, so it's rusty red. And at the top, you've got your Ferriby Chalk Formation, which is a white or grey chalk, very similar. It's a little bit more dense, but very similar to the kind of chalk that you would find down at the White Cliffs of Dover. Well, let's throw some dates out there. You see, the carstone at the bottom is supposed to be 109 million years old. The red chalk in the middle is supposed to be 101 million years old, and the Ferriby chalk at the top is supposed to be 99 million years old. Now, again, I don't agree with these dates, but bear them in mind, because what we're going to do is actually try and test these dates against themselves. I mean, the Bible says to test everything, so we're going to come on to that in just a moment. But just talking about the geology, Hunstanton is a beautiful place, and it's full of fossils, including those great big giant ammonites. In fact, this particular fossil ammonite we found even had a shark tooth embedded in it and a sea urchin stuck on the side. And as we were down on the beach, we went for a quick beach comb, and yep, we found a modern day one. There they are side by side. No evidence of evolution in, how old is the Ferriby chalk? 99 million years? Yeah, no evidence for evolution there at all. And you find fossil brachiopods. What are brachiopods? Well, there's the fossil one there, about 5 centimetres tall. That's how they live today. Yeah, they're living fossils, no evolution after their kind. But can you see the little stalk that comes out the bottom, anchors it to the bottom of the seabed, and the shell opens and closes? Well, there's the little stalk there. That's the way that they live in the wild. Now, standard geology would tell you that fossils form when a creature lives, dies, and gets buried where it's been living. Do you want to know how we find every single one of these fossil brachiopods? Turned upside down like this. You see the little hole where the stalk would come out of? It's lying upside down. It's also, by the way, the little shell is cutting through many, many layers of rock. It's passing up through many layers, and we have a word for that. It's called polystrate. Poly means many, strate refers to strata or layers. This is a fossil that's cutting up through many layers. And yet each layer is supposed to form extremely slowly and extremely gradually. In fact, the standard idea for chalk formation is based off of a principle known as uniformitarianism. That's the present is the key to the past. So we go and have a look at where chalk is forming today, and we assume that's how chalk has always formed. Today, chalk forms by all sorts of little planktonic shells filtering down through the sea and building up into something called calcareous ooze, which is a lovely name, and we can go and observe it today. Do you know what it doesn't have in it? It doesn't have any fossils in it. Because it's forming so slowly, any living creature that falls down into it simply gets destroyed, even the shells. Do you know what it also hasn't got? Pure white chalk. I mean, the chalk of the White Cliffs of Dover is some 99% calcium carbonate. It's almost pure mineral. And yet the calcareous ooze we see today is full of stuff like fish poo, full of stuff like contamination and muck and silt and sediments. It's not the lovely pure stuff that you see out in the geological rocks. Well, let's go back to these dates for a moment. 109 million years at the bottom, 99 million years at the top. Now, I know it's late on a Friday evening, but we're going to do some mathematics now, and hopefully we'll be able to follow along. 109 million years, that's the age of the bottom, right? Minus 99 million years, that's the age of the top, equals 10 million years. In other words, according to the dates, it took 10 million years to lay down all the rocks found at Hunstanton. Are we all following so far? Okay, that's nice and simple. We're going to step it up a little bit, because you see, the height of these cliffs, the thickness of this deposit, is supposed to be 20 metres thick. In other words, according to the dates, it took 10 million years to lay down 20 metres worth of sediment. Well, now comes the slightly more complicated maths, because what we're going to do is we're going to take 20 metres and we're going to express them in millimetres, which is, of course, the beauty of the metric system, because 20 metres is 20,000 millimetres. And so we're just going to do that to make it a little bit easier to understand, because what we want to do is take 20,000 millimetres, that's the amount of rock there is, and divide it by 10 million. That's the amount of time that it supposedly took to lay down. What we're doing is working out how much sediment, bearing in mind chalk is supposed to be a slow and gradual deposit, and that's well established in the scientific literature. It's a slow and gradual deposit that builds up gradually and consistently over vast periods of time. So you work out how much time is represented in the rock, and you divide it by the amount of time it supposedly took to lay down, and you get your calculation of how much sediment was being deposited every single year according to the dates. The answer is 0.002 millimetres per year. If you want that in Old English, that's 0.007 inches per year. Now, most of us can't put our fingers that close together. That's a ludicrously small amount. And I use that word deliberately, as you'll see in a moment, but here's the simple point. You remember those fossils? The brachiopods? You remember how they sit upright in the rock, cutting up through many layers, around 5 centimetres tall? Well, at those rates, it would take over 14,000 years per inch of sediment, or 28,000 years just to bury the brachiopods. Now, that's a lot of time. Question, if you leave a seashell out for 28,000 years, how much seashell will you have at the end of it? Because that's not even fossilising the seashell, that's just burying the thing. So don't be surprised that it's actually one of your Welsh professors that really realised the stupidity, if you like, of some of this millions of years philosophy, because Professor Derek Ager said this: if one attempts to calculate the rates of sedimentation in the past, that's what we've just done, the results are usually ludicrous. And they really are. By the way, you can take this principle and apply it just about anywhere. You can apply it to your local fossil beaches, you can apply it to the Grand Canyon, you can apply it to pretty much anywhere on the planet. All you have to do is a little Google or a little read of your local geology book, find out the age at the bottom, the age at the top, work out how thick it is, and do your simple calculation, and the results will be ludicrous. And of course, the beauty of this calculation is that mathematics is absolute. It's an absolute result that we get at the end. The only room for error is the data that you put into it. Well, what data did we put into it? We put in the thickness of the sediment, the thickness of the deposit, and we put in the supposed time it took to form. Now, one of those is observable. One of those is not. If you want to question the thickness, you can simply go and observe it. You can take the British Geological Survey's word for it, or you can go and measure it yourself. You see, the only arbitrary data that's been put in there is the time. Therefore, it's the time data that's the problem. You see, as I have said already, fossilization has got nothing to do with time, but everything to do with a process. And despite it being well established in the scientific literature that chalk is supposed to be a slow and gradual deposition, a consistent deposition, some of the critics we've had who've criticised this kind of point that we're making would say this: well, of course deposition would not be constant when forming. You would have vast amounts of deposition, followed by millions of years of nothingness. Well, there's a very simple solution to that. What does the evidence indicate about deposition? Well, at Hunstanton, we have fossils that have clearly been buried rapidly, found all throughout the deposit. But what evidence is there for currents and flowing water? Well, that was actually the subject of my undergraduate dissertation. It's up on the website if you want to go and read it, a 3-month research project into Hunstanton, and we specifically looked for the evidence of transportation. That's fossils that have been transported into place by flowing water. What did we find? 93% of fossils showed transportation. Now that included the brachiopods being turned upside down, that included the squid-like fossils, the belemnites, all being pointed in the same direction, that included smashed up and broken up fossils, which simply tells you that all these fossils were formed in water flowing in one direction, having been caught up in a slurry of sediment before being buried rapidly and then fossilized. You see no evidence of a bit of a stream, then a bit of nothing, then a bit of a current, then a bit of nothing. You find this evidence all the way consistently up and down Hunstanton cliffs, which means it all formed at the same time, like elsewhere around the planet. This is up from Whitby Way. See all the squid-like fossils pointing almost all in the same direction? Yep, good evidence that they have been washed into position, good evidence that fossilization has got nothing to do with time, but everything to do with the process. Remember Professor Ager's point? If one attempts to calculate the rates of sedimentation in the past, the results are usually ludicrous. They really are. Well, let's take a little bit of a step back. We're looking for evidence of a worldwide flood, the day that the world washed away, so we need to take a bit of a step back into a more global perspective. But we're going to start back in the UK and move our way out, and we're going to start our place in Edinburgh, particularly Edinburgh Botanic Gardens. And on display in Edinburgh Botanic Gardens, there's a fossil tree. But this tree was not found in Edinburgh Botanic Gardens. This tree was found a little way away in Craglith Quarry. And in fact, it wasn't found like that either. You see how it's laying down on display? Well, here in the Edinburgh Geological Society's annual report, this is the picture that they published of how that tree was originally found. You see the little man there, you see the tree, and you see all the rock layers. This tree is passing up through many rock layers. We had a name for that, the same name as with the little brachiopod fossil from Hunstanton. This is a polystrate tree. Poly meaning many, straight meaning strata or layers, and yes, these polystrate trees are found all around the world, including in places like Tennessee and Kentucky. There's the fossil tree. You can see all the rock layers. It's a polystrate tree, a tree that is cutting up through many layers. Now here I am with 2 ex-US Marines. And the reason I'm with 2 ex-US Marines is because we're about to go into the middle of the wilds of Tennessee. And yes, there are still parts of Tennessee which are pretty wild. I mean, there are things like bears out there, and things like elk, and things like hillbillies. And so I thought it wise to take a couple of US Marines with big guns with me for my own safety, because we were trekking our way through the wilderness. I mean, we're really genuinely out in the wilderness here. It's about 8 miles off the nearest road, down through a track, until you get to a clearing where you have to get into these sort of off off-road vehicles and drive up the mountain for about another 4 or 5 miles, and you've got a 3-hour hike at the end of that up the mountain until you find an old, well, it looks like a valley, but it's actually an old scoop mine where they just literally came in and scooped out all of the coal. And as you follow this mine along, you can find a polystrate tree. In fact, there's a whole load of them, and they're some of the best preserved polystrate trees we've ever found. I took my colleague, Dr. Glenn Wilson, out with me. Definitely a polystrate tree. See all the layers? See the tree passing up through the layers? Well, what's the significance of these trees? Because they're not just found in Tennessee, and they're not just found in Kentucky, and they're not just found in Scotland. They're found all over the world. But try as you like, you will very rarely find any reference to these in the scientific literature. In fact, the only reason we knew about these trees is because back in 1975, National Geographic published a picture of one. And they said, here is a fossil tree in a mine in Tennessee. And they made no reference of how it got there, no reference of how it was buried or preserved, no reference of any kind of significance. They didn't even tell you properly where it was. It took another sort of 30 years before they ended up being tracked down. But if you go far enough back in the literature into many of the things that are now out of print, you can find some reference to these trees, particularly the Geology of the Manchester Area by Eager and Broadhurst. Now out of print, but on the back cover, there is a picture of a polystrate tree. Well, we wanted to go and track it down, and this is back in the days where they filled up your geology book of directions of, turn here, turn right here, go left of that tree, and you'll find this fossil. So we went to track it down. It was quite overgrown. There used to be a big viewing platform. That viewing platform is now completely rotted away. There used to be a big signpost. That signpost has now been removed. There used to be a gate leading you to the tree. That is now fully overgrown with no path leading to it. But if you follow the instructions in the book, you do eventually find a slightly worn but very real polystrate tree in Manchester. I took a young worker out with me to help do all the hard work cleaning it up. I got to take the fancy photo next to it. But the book is quite interesting because it tells you something about how this tree got there. You see, by their own admission, the tree was apparently overwhelmed by flooding. It is a flood deposit. And in fact, it's a flood deposit, and it isn't the standard story with these trees, which is that they lived in a swamp, they died in a swamp, and they got buried in a swamp. Because if you follow this tree, you can see where the edge, the bark, has turned to coal. And if you follow it all the way down to the bottom, there's something quite remarkable. You see, the bottom of that tree is actually balancing on top of another tree. You've actually got a tree on top of another tree. You've actually got one that's ploughed itself into the underneath. Well, that's not how it lived and died and got buried. It's definitely a flood deposit for sure. And it's good evidence of fast flood evidence. But how did they actually get there, even under a flood scenario? Well, these trees, as I said, were supposed to have lived, died, and been buried in a swamp. So let's go to a swamp. Question: where is the water level normally in this swamp? Any ideas? Because if you look closely at the trees, you might be able to spot it. Can you see the changing colour? You see, that's where the normal water level is. Because if you get up close to these trees, you can actually see that the bottom of them are a much darker colour, which is known as differential rotting or differential weathering. In other words, as the water rises and falls, it begins to weather the bottoms of the trees, so you can actually see these key things, these key factors of a swamp stamped into the very way that the trees grow. You see, there's a swamp, and if you buried that swamp and fossilised it, what would it show? Well, it would show soil, because these trees are growing out of soil, so if you buried it in rock, there should be a layer of soil. You'd see differential weathering at the base of the trees. You'd see branches, but there'd be no leaves, because all the leaves have turned into soil. And there should be no blast damage whatsoever. Well, let's go to another place where you find these trees. Newcastle, Australia. A number of years back with our good friend John Mackay, the director of the ministry, and he's showing me some very famous trees. You see, there's a funny story associated with these trees. You can find them down on the beach, they're fossils, and many of them are lying flat. Many of these trees that are lying flat are pointing in the same direction, mostly in a northeast-southwest direction. Good evidence of flowing water that have washed these trees into place. But as you get up to the cliffs, some of these trees are standing up vertical. They are polystrate trees. There's a whole number of them up and down, and these rocks are supposed to be 255 million years old in the Permian. By the way, Permian rocks are named after Perm in Russia, because it was the Russian Tsar, who was a relation of Queen Elizabeth, who allowed the British geologists to come over and study the rocks, and to thank him, they named one of the rocks after the place where he was born, Perm in Russia. Nothing to do with millions of years and evolution, everything to do with where they were first studied. But this is one vertical fossil pine tree. Now you've got an immediate problem if you want to argue that this lived, died and got buried in a swamp, and that is that pine trees don't grow in swamps. And yet this is so well preserved, we even know what kind of pine tree it is. It's one of the Araucaria. It's a living fossil. No evolution whatsoever. Well, you can trace these fossil trees right down to the coal base where they are sticking out of. Now remember, this coal base is supposed to be the peat layer of the swamp that has turned into coal. Well, what do you find buried in there? Great fossil leaves. Hang on a minute, where's the soil? No, there's no soil there whatsoever. There's fantastic fossil leaves, but not a single one of them belongs to the trees that are coming out of them. There are no pine needles and no soil whatsoever. You see, we are dealing with something that is clearly very different to the standard story of how these trees got to be there. In fact, you can do some very simple research to show you how these trees did get there. And you can do it yourself with a jam jar and a few matchsticks. You see, welcome to our Jurassic Ark Research Centre. And we've got our polystrate test tank here. You see it? It's a big fish tank. We've filled it up with water and we've lobbed a few sticks in it. It's highly sophisticated stuff. But it does show you, in a very simple way, how trees and twigs and sticks and indeed any plant material behaves when suspended in water. You see, when the trees are alive, when the plants are alive, they transport water through them in one direction, from roots to leaves. And it turns out that this mechanism still is in place even after the trees have died. So you can put these sticks in water, and after just a couple of hours, they begin to tilt. Because as they begin to get waterlogged on the end that they absorb the water in, it becomes water heavy, top heavy, and they begin to tilt. A few hours later, that's what they look like. A few hours more, and many of them are standing vertically. Some of them have fallen all the way to the bottom. Many of them are still floating on the top. But a number of them are actually floating almost horizontal. Indeed, like I said, matchsticks do exactly the same thing. This was at a big conference that we had last year. We wanted to sort of showcase some of the experimentation. It's just a smaller tank filled with water and a load of matchsticks. Many of them are floating. Some of them are standing vertically in the water. Some of them have sunk vertically all the way to the bottom and are standing upright out of a mat of lying down flat logs and matchsticks. By the way, you've got things lying down flat, things that if they were buried might turn to coal if they were under the right conditions, many of them floating at the top, and a few of them standing vertically. By the way, that's exactly what you find across the planet with these polystrate trees. All of them stick out of a coal bed. No soil, no roots either, because they've been ripped up. They have no branches where the branches have been stripped off. And if you follow the deposit high enough to the top, you find a log jam of flat, lying down, horizontal logs. Just like you see if you do the experiments in the real world. Quite fascinating stuff, but here's a big question. Just how big are these Carboniferous Pennsylvanian coal beds where the majority of polystrate trees are found? Well, we'll go back to our Welsh professor Derek Ager, and this is what he had to say. The Carboniferous, by the way, a little bit of politics if you like, because you see the geological column with all the millions of years was named by us Brits. And it was actually a really important part because, of course, the Brits and the British Empire were going through the Industrial Revolution. And the coal was really important, particularly the coal here in Wales. And so it was the British geologists and the Welsh geologists and the Scottish geologists that invented the geological column, and they named the rocks which the coal is in the Carboniferous. Why? Because it's full of carbon. It's as simple as that. The Americans are a rebellious lot, and they don't go with the British names, and so they actually took the Carboniferous. We have upper and lower Carboniferous. They took the upper and lower. They already had it split in two, but they named it the Pennsylvanian and the Mississippian. Nothing to do with millions of years in evolution, everything to do with where it was first studied. And yes, you can trace the Pennsylvanian rocks from places like Mississippi and Tennessee up into Pennsylvania, over the border into Canada, where they're still loyal to us, and they call them the Carboniferous rocks in Canada as well. So back to Professor Derek Ager. The Carboniferous extends in essentially the same form from Texas to the Dantes Coal Basin north of the Caspian Sea in the USSR. Yeah, slightly dated reference, but it makes a very good point. There's Texas, there's the Caspian Sea. This amounts, he says, to some 170 degrees of longitude, and closing up the Atlantic by a mere 40 degrees does not really help at all that much in explaining this remarkable phenomena. In other words, flood deposits go across the world. And even more remarkable, since Professor Derek Ager wrote this book, the Carboniferous deposits have turned up on the west coast of Australia. Yeah, flood deposits really are worldwide indeed. And we have our fair share of these polystrate trees here in the UK as well, including this one from Northumberland. By the way, the Carboniferous rocks yield something else quite important as well. You see, this was a field trip that we did just a few years back, just after COVID, in fact. Great geology, lots of things to talk about, and there's Mamtor in the background. We're in Castleton, which is in the Peak District, and we're in those black rocks. Those black rocks are the Carboniferous rocks. And as we were explaining how to dig and how to find fossils, this is one fossil that we found that you might be able to recognise. Can you spot the fossil thorns? The sharp spiky bits coming out of the side of them. Well, you see, these Carboniferous rocks with these fossil thorns in them are supposed to be some 304 million years old. That's some old rocks. But of course, you have to ask, according to the Bible, are they really 304 million years old? In fact, in Northumberland, where we have these polystrate trees, if you dig around in the coal basin, these rocks, again Carboniferous, supposedly some 318 million years old, you find fossil thorns there as well. Spiky things sticking out the side of the plants. According to the Bible, are these rocks really 318 million years old? Now, according to the Bible, these rocks cannot be 318 million years old for one simple reason. Thorns and thistles are explicitly told in Genesis chapter 3 that they are part of the curse that God put on the planet after Adam sinned. Then God said to Adam, "Because you have heeded the voice of your wife and have eaten from the tree of which I commanded you, saying, you shall not eat of it, the ground is cursed for your sake. In toil you shall eat of it all the days of your life. Both thorns and thistles it shall bring forth for you, and you shall eat the herb of the field." You see, the Bible is explicitly clear. Thorns and thistles are the result of God's judgment on man's sin. And so if they're the result of God's judgment on man's sin, then they couldn't have been on the planet until man was on the planet to sin. Which means that according to the Bible, these fossil rocks with the fossil thorns in them must be less than 6,000 years old. By the way, there's another thorny plant. That thorny plant was found in the Ordovician rocks, supposedly some of the oldest rocks on the planet, which have fossils in them, in Tennessee. So we've found them all up and down the geological column. There's no doubt about it. Fossil thorns tell you that the world cannot be millions of years old, according to the Bible. Well, let's look at one more final piece of evidence before we begin to wrap it up. Because you see, it's all very well jumping around the planet and looking at lots of evidence, and yes, we do need to take the big step back. We've done that with the Carboniferous. The fact that you've got flood rocks across the planet in the Carboniferous tells you that there must have been a massive flood on Earth at one point. But we're going to show you one fossil deposit. Not one rock deposit, not one rock layer, one fossil deposit that shows that there must have been a global flood at some point in Earth's history. And to do that, we need to go to Australia. And down in Australia, there's a place called Jurassic Ark. Jurassic Ark is Creation Research's outdoor creation museum near Gympie. And we take lots of school visits there. Yes, you can come and see the dinosaurs. And yes, if you come to Jurassic Ark, you get to go at digging up real fossils. Because you see, Jurassic Ark is called Jurassic Ark because it's built on Jurassic rocks. And there's a very real flood deposit there. There's the Jurassic rocks. We've been digging it for a number of years. And the types of fossils you find on these rocks that you can come to Jurassic Ark and have a go at digging yourself are fossil trees. Fossil trees, by the way, with no branches. Fossil trees with no roots. And fossil trees that are buried with boulders. I wonder what all this means. And yes, there are polystrate trees there as well. There's the rock layers labelled strata. There's the tree standing up through the rock layers. So it tells you one simple thing, the same thing that all polystrate trees tell you. The strata, the rock layers, must have been deposited in less time than it takes a pine tree to rot. And here's Gary exposing a rather large tree from the deposit. And in fact, you can trace the tree all the way down to the base where there's a root ball, but there's no roots. The roots have been torn off. And at the top of the tree, there's a giant boulder. And many of these boulders are pretty big. Many of these boulders are up to 0.5 metre or 18 inches across. And by the way, large boulders like this indicate very fast-flowing water, especially when they're buried next to logs. Because you see, there's a very simple point. Logs float and rocks don't. So if you want to get the two of them buried together, the water has to be travelling fast enough to actually carry both of them at the same time. So don't be surprised that we've labelled this flood deposit a fossil flood log jam. And yes, we believe it points to Noah's flood. We'll come on to that in a moment. Now, you know it's a log jam because you can go and see modern-day log jams. There's a landslide log jam, a log jam from a landslide in the USA, where the landslide has slid down the mountains and washed all of those trees into the river, where they've begun to be swept along by flowing water. There's no branches, they've been ripped off. The root ball has been torn off, and the ends of the trees get abraded as they bump into each other, floating down the stream. By the way, our fossil ones from Jurassic Ark show exactly the same thing. There's the fossil one on the left, there's the modern day one on the right. They both have pointy ends because they've both been swept along by water. This fossil deposit is a flood dump for sure. Oh, and by the way, I've already mentioned pine tree, but they are southern conifers, and we have southern conifers growing on site at Gympie. They haven't evolved at all. They've simply reproduced after their own kind. Well, what else is there? What other evidence? Well, all the logs are pointing in the same direction. They all point in a southwest-northeast direction. You can trace it across the whole deposit. Southwest, northeast, southwest, northeast. So, what evidence do we get from this single deposit? Well, there's orientation. They're pointing in the same direction. They're broken trees. They've been stripped of their branches and ripped up by the roots. There's abrasion at the end where they've bumped into each other as they've clearly been flowing in water. It's a mixed dump because you find shells and pebbles and all sorts mixed up in there. Giant rocks and boulders buried next to them, which tell you that water must have been flowing fast enough to carry both of them at the same time. All of these show evidence of flood deposition. So it's definitely a flood deposit for sure. But how big is this single fossil log jam? Not the geology that they're buried in, not the rock layer that they're buried in. How big is this single flood log jam? Well, there is, in Australia, the Jurassic flood log bed. That takes up quite a bit of Australia. By the way, there's Australia with the UK. There's Australia in the UK with the flood log bed. Now think about this. The rock that they're buried in is sandstone. Sandstone is, by definition, sand is a reference to the size of the particles that have been, the size of the particles of the sediment in the rock, that have been glued together by something, usually another mineral, usually iron, or like a limestone. In this case, it's mostly iron. But that sand had to come from somewhere else. And sand doesn't just naturally appear. Sand comes from eroded rocks. It comes from other rocks that have been eroded down, usually, and you can usually, with the sand, in the sandstone, trace it back to the type of rock that it's come from. Usually, it's a granitic type rock, a granite. But think about this. It's a huge sandstone bed full of these logs. Every cubic metre of sandstone requires approximately 3 times, so 3 cubic metres of other rock that are to be destroyed in order to produce the sand to bury these logs. In other words, just to get this single log jam in Australia, it would require a flood of global proportions in order to erode the sediment in the first place, in order to flood the land and rip up the trees and mix them all together, and then to deposit them all in one place. You would require a global flood just for this single log jam in Australia. Now scale it up to the fact that the Jurassic rocks are named after the Jura Mountains, which means that they've gone across the planet, which means you can find these rock layers all across the planet, and you've got no doubt about the existence of a global flood at some point in Earth's history based on the evidence. By the way, it's starting to sound an awful lot like Noah's flood. And I had a young student, I was lecturing in the States, and I had a young student say, how can I bring this evidence of Noah's flood into my university degree? And I said, well, whatever you do, don't make your next university thesis on the value of Noah's flood in modelling sedimentary deposits in Earth's history. For one simple reason, you will get thrown out of university, or at least marked down. And that's for a very simple reason. The science teacher, a few years back, said this: scientific theories are therefore explanations about aspects of nature without reference to God. Now, a few hundred years ago, Kepler, who revolutionised the way that we view planetary motion, he said that science was thinking God's thoughts after him. I think that's one of the best explanations, or definitions if you like, of what science is. God does it, we try and work out what he did. So how did we go from science being thinking God's thoughts after him to scientific theories being nothing to do with God? Well, a lot of it has to do with this man, Charles Lyell. Charles Lyell was a Scottish lawyer. And you can see his catchphrase there, the present is the key to the past. And you can see the principle which his catchphrase alluded to, which he introduced in his book, The Principles of Geology, which revolutionised the way that people think about the world around them. Uniformitarianism. The idea that the world is uniform. In other words, if we see a tiny little river eroding a tiny little gully away today, boy must it have taken millions of years to form the Grand Canyon. If we see tiny amounts of calcareous ooze forming today, boy must it have taken millions of years to form the White Cliffs of Dover. If we see tiny amounts of sand being built up on a beach today, boy must it have taken millions of years to form the huge sandstone beds that would have buried the logs in places like Jurassic Ark in Australia. And it's all done, by the way, based on the present being the key to the past and in ultimately ignorance of what the evidence actually says. Things like polystrate trees, things like the fact that the calcareous ooze today doesn't have fossils and the chalk has lots of fossils. Things like the fact that if you took that amount of time to erode the sediment, you would never get a log jam that covered nearly a quarter of Australia. And by the way, it's an anti-biblical principle as well. Because the Bible doesn't say that the present is the key to the past. The Bible says that the past is the key to the present. What happened in the past explains how we got here. What happened in the past explains the mess that we're in. And Christ was slain before the foundations of the earth. In other words, what happened in the past explains how we get salvation. Christ's plan was always to save us from sin by dying on a cross. So you can begin to see what this rather crafty Scottish lawyer, Charles Lyell, was actually doing when he promoted his idea of uniformitarianism and promoted his idea that the present is the key to the past. By the way, if you don't believe me, let's listen to his own words. My aim, says Charles Lyell, is to free science from Moses. Now there it is, bluntly and as plain as day. I mean, think about it. Moses, Genesis, Exodus, Leviticus, Numbers, Deuteronomy, one of the Psalms, Psalm 90, possibly Psalm 91, we don't know. But you see, if his aim was to free science from Moses, in those first 5 books of the Bible, we find the foundation of all of Christianity. Because if you get rid of a creation, not only do you get rid of a God who created and therefore has a say over his creation, you get rid of a supernatural creation, which means that we must have evolved from nothing, which means we're not accountable to any God. By the way, it also means that mankind is not specially made in God's image, which means that we're no different from the animals, which means, by the way, that I can treat you like an animal. Do you see the problem with that? If there was no sin, original fall of mankind, as the old theologian said it, not only do you get rid of sin, which is breaking God's law, who doesn't exist because he didn't create anyway, you also get rid of the answer to things like, why would a good God let bad things happen? Spoiler alert, it's our fault. We're the ones who messed up. That's why we need a saviour. You also get rid of an origin of death, because it was because of man's sin that death came into the world. Romans, that's a wonderful legal letter that Paul is writing in Romans, and, so whoever the author of Hebrews is as well, because they tie together so nicely, Romans and Hebrews. But you see, the whole point of it is that it's by one man, Adam, that sin entered the world. That's why we need one sinless saviour. And if death is just a natural part of creation, then ask yourself the question, what did one extra death in Jesus Christ actually achieve? If death is just a natural part of all of creation. Get rid of the global flood described in Genesis, and not only do you get rid of a huge amount of geological history that we've talked about today and the evidence of it, but you also get rid of a God who can judge, a God who has a right to judge, a God who has judged in the past, and a God who has promised he will judge again in the future and continues to judge today. Now, if such a God exists, then he probably has a few rules that we ought to be following. Maybe that gives us the answer to the question, why do so many people reject the evidence of a global flood? If you get rid of the Tower of Babel, you get again rid of a God who can judge and does judge his people, actively judges his people, but you also get rid to the answer of questions like, why are there different racial groups? Why are there different skin colours? Why are there different people groups? And you're left with a very racist idea that Charles Darwin promoted, which is if you have a different skin colour to me, you must be less evolved. That's a horrible racist thing, but it's ultimately where Charles Darwin's ideas lead to. His book, The Origin of Species, no, that's just the first part on the origin of species by means of natural selection or the preservation of favoured races in the struggle for life. It's a very racist ideology. It's there in the title. And if you get rid of the law of God, you get rid of any basis for morality whatsoever. You are left with no way of knowing what morality is, no way of knowing what right and wrong is, therefore you can behave however you want. You see, Charles Lyell knew exactly what he was doing when he promoted millions of years and ultimately evolution, which Charles Darwin promoted as well. He didn't invent it. The ancient Greeks had an idea of evolution. There's a program up the back there called The Pagan Roots of Evolution. If you want to trace it back, it goes all the way back to the ancient Babylonians. It's amazing how far back some of these ideas go. You see, the point is very simple. It's not the evidence that disagrees with the biblical record of creation and Noah's flood over the last 6,000 to 7,000 years. It's the opinions of men who willfully set out to reject and replace the word of God. That's the point that Peter was making in 2 Peter chapter 3. He says that there are scoffers that are going to come, and they're going to scoff two things in particular, creation and Noah's flood. So don't be surprised that that's where the attacks really come from today. Oh, by the way, to finish, you remember those fossil thorns? There's some that we found in Canada. There's no disputing what those things are. Question, if the dinosaur layers are found above the thorn layers, then that must also mean that the dinosaur fossils formed after Adam sinned. Because the thorns only came onto the planet after Adam sinned. And all of a sudden that puts me at odds with all of my geological fellows in the Geological Society. But you see, the big question which you have to challenge yourself with, and I do challenge many people with, is who is your authority? Is it God's word or is it man's word? You want to know the gospel from beginning to end? Because you see, the whole history of the world, according to the Bible, is good to bad to worse. Now, that's a really depressing place to end. But let's throw some good news in there. What do we call the good news? We call it the gospel. The gospel is that the world has changed, but God has not. Christ the Creator made a good world with no thorns. Christ the Judge cursed the world with thorns. And then ask yourself, what did Jesus Christ die wearing? A crown of thorns. He died wearing the very symbol of the curse that he was dying to set us free from. Christ the Saviour died with thorns so that Christ the King can rule over a new world where there will be no thorns. Revelation 22, there shall be no more curse. And in fact, that New Testament reference to a curse only makes sense if it is a reference to the very literal Old Testament curse that was put onto the planet when man sinned, which will be lifted in the new heavens and the new earth, where there shall be no more death, where there shall be no more disease, where there shall be no more sin, where Christ shall reign over all, and there shall be no more thorns. My final challenge to you, take off Charles Darwin's glasses and start seeing things God's way. Oh, by the way, this is Charles Darwin's statue outside of the school which he attended, less than 20 minutes away from our current Creation Museum. No, we didn't plan that. It seems like God has a sense of humour sometimes. But it really is an important point. Take off Charles Darwin's glasses and start seeing things God's way. Let me leave you with where we started. Let this mind be in you that is also in Christ Jesus. Philippians chapter 2, verse 5. Start thinking about the world the way that Jesus Christ thinks about the world, not the way that Charles Darwin thought about the world, and things will make a lot more sense. For one simple reason, Charles Darwin is dead. Jesus Christ is alive. Charles Darwin's a creationist now. He absolutely believes that God created the world because he had to stand in front of his creator and actually give a statement for all the words that came out of his mouth. Or maybe that's to come. But you see, regardless of your view of eschatology, the point is that we will all have to give an account of every single word out of our mouth. And it was Charles Darwin who said, I came to realize that the words of the Holy Scriptures were no more to be trusted than the ancient sacred texts of the Hindus. He'll have to give an account of his words, and so will you, and so will I. So let this mind be in you that's also in Christ Jesus, because Jesus is alive and he is the one who can save you from your sins. A reminder, creationresearch.net is the place to go if you would like to find out more about the work that we're doing across the planet, and there are plenty of resources available both from there and up the back this evening. So we'll call it to a close there, and I hope you've enjoyed. I trust it's been useful for you, and I think we've got some time for some questions now as well. Go for it.
There was one other place where the Hunstanton formations.
Yes. Yorkshire coast. It's the name escapes me, but I think it's Filey. But yeah, it's in Yorkshire, and basically dips down underneath all the other rocks that goes up the wash, and then erodes a bit away. You can see where it might have been, but it's been eroded away. But then it turns up at Filey, up the Yorkshire coast.
One of the arguments, I'm playing devil's advocate.
Yeah, sure.
I don't believe this. There is, the idea that all the continents were one big landmass at one time. Mm-hmm. And so there was a limited flood, and then of course they all separated, and you get all the stuff.
Yeah. Well, essentially, if you have, there's two things. Number one, there is very good evidence that all the continents were together at one point in Earth's history. Aside from the fact they just fit together, you can also actually trace, the Carboniferous is there in the States, it's here in the UK, and it's all across Europe, and you can actually see where they all fit together at one point, and there's nothing underneath the sea. So it's very clear there's been one deposit that's broken apart. In fact, you get that indication in the Bible, Genesis chapter 1, day 3 of creation. God says, let the waters be gathered together into one place, and let the dry land appear. So there is a picture of one water mass, one land mass. Now, even if you put all of it together, and that's the point that Professor Derek Ager was making, right? He said that if you close up the Atlantic by a mere 40 degrees, it doesn't help in explaining this phenomena, right? And he's basically saying, look, at the moment you've got 170 degrees worth of Carboniferous deposits. We now know it's a lot more than that because it's turned up in Australia. Even if you put all the Earth back together again, you're still dealing with a vast deposit that covers all of the continental surface, which means you'd still need a global flood in order to do that, right? And so there is good evidence of one land mass that broke up rather than continental drifting. I think we're more looking at continental sprinting, right, during Noah's flood as it breaks apart. But even if you put it back together, you're still dealing with, as the same point, just that one log jam in Australia, which is in one continent itself, right, still shows that you'd need a global flood to produce that volume of sediment. So that is one of the arguments, but it doesn't really help you get much further. It's still a big flood. It would still require a flood of global proportions to produce that volume. So you do have indication of one landmass that got covered, ripped up, churned around, deposited down, and towards the end of the flood, broke up and ended up in the sort of land masses that we have today. But they were all one sort of major continental mass at one point in Earth's history.
So we've seen overwhelming evidence for that there was a flood at some point. Where would you go to find out indications of when this flood that we're seeing, how far back it would go from a scientific point of view?
Yeah. From a scientific point of view, you have to be careful because so much of geological science is a historical type of science, which has a number of, you could say, presuppositions, or certainly a lot of pre-understanding, which is applied to geology. And that goes beyond things like dating methods, right? People believe that the Earth was millions of years old long before the first ever dating method was invented, right? And that is because it is a philosophy and not an evidence-based piece of science. That comes from Charles Lyell, who was known to have produced frauds in the sense that he went to places like Niagara Falls. He asked the locals what the rate of erosion was. The locals told him what the rate of erosion was. He thought that sounded far too fast for his theory, so he cut it down by 1/10. And we now know that the locals were pretty much right on their rate of erosion, right? So it's known fraudster in the sense that you're refusing eyewitness accounts and you're going by your own ideology. So if you were to go to the average scientist and say, okay, there's clearly evidence of worldwide flood, how old ago was it or how long ago was it? They would still think in the ways of lots and lots of little local floods, even if it was an almost global flood, because at one point in Earth's history, almost 90% of the Earth was covered in water, even by secular conditions, right? But that was happening millions of years before other rock layers or after other rock layers have been formed, right? So you're still viewing as the layers of rock are successive time zones, which slowly build up over millions of years. There's a number of problems with that. Number one, it doesn't exist, as in the rock layer, the geological column doesn't exist anywhere on the planet. Right? I mean, even at the Grand Canyon, which is one of the best records of rock layering that we have on all of the globe, 96 or something % of the time is missing. Right? The geological column doesn't exist. You have to piece it together from lots of different places and make a lot of assumptions which are based off of evolutionary history and piece them all together. So that's the first problem. The second thing is, if you want to take a purely objective scientific view, you can come to the conclusion that whatever flood produced all these rock layers can't have happened very long back. That's where the soft tissue stuff comes in, right? Other than the fact that you're definitely dealing with a flood because of the level of preservation, right? You know, brilliant fish fossils and so on and so forth. The fact that you have original biomaterials. Now, I prefer the term original biomaterials than I do soft tissue. And this is a little bit of a side note, but there's a very well-known Facebook page that calls itself Biblical Creation, puts out lots and lots of posts about biblical creation. 90% of the stuff is great. But they put it out just a couple of days ago. There was a report in Nature, quite prestigious journal, which the title was Soft Tissue Preserved in a Fossil Ichthyosaur, one of the big swimming type dinosaurs, right? And all the creationists on this Facebook had jumped on it. Look at this evidence of soft tissue in this dinosaur. What they didn't find was soft tissue as we're thinking. What they're finding is preserved soft tissue, in other words, skin impressions and sucker impressions, right? In other words, soft tissue, as in squidgy skin, preserved as a biolayer. In other words, it's turned to rock, but it's left an impression of where the skin was, which tells you something about how the creature looked. Now, that is brilliant evidence of rapid fossilization. Brilliant evidence of really quick. But is there anything organic left? Is there anything soft and squidgy left? No. And so soft tissue has two meanings. It can mean preserved soft squidgy stuff, like skin impressions, or it can mean soft squidgy stuff that's still there in the bone. What I'm doing is soft squidgy stuff that's still in the bone. But not everything that people call soft tissue is soft squidgy stuff left in the bone. So that's why I prefer the term original biomaterials, because it is literally they are the original biomaterials from the bone left in the actual bone. Now, that has got a shelf life. And so biomaterial, like collagen, is a protein, And think protein, think meat, right? Meat protein. So if you get a lovely steak and you put it out on a hot summer's day, what's your shelf life of that steak? A couple of hours? Well, what could you do to that steak to prolong the shelf life? Well, you could put it in the fridge. Now you've prolonged the shelf life from a few hours to maybe a few days. So there certainly is the case that you can prolong shelf life of biomaterials by preserving them in a certain way or putting them under certain conditions. You could put that steak in the freezer. That would prolong it from a few days to a few months, maybe even a few years. But it's still going to eventually break down. One of the best ways of preserving biomaterial is permineralizing it. Think salt beef. You are permeating it with minerals. That can last hundreds of years, maybe even thousands of years. But you still have got a shelf life. It is still going to break down. It is still going to decay because it is now dead. And all living things, when they die, if you want the biology, all living things are made up of proteins, which are made up of peptides, which are made up of amino acids, and amino acids come in left and right-handed forms. And in biology, only left-handed amino acids exist. Your body is actively fighting to keep yourself only left-handed amino acids. The moment you die, they all begin to divulge back to left and right-handed amino acids. And it doesn't matter how much you do to them or what you do to them or how well you preserve them, that process is ongoing. In other words, biomaterials have a shelf life. And it's true, under our current thinking, the people who are experts in ancient collagen say 1 million years. Most biologists say actually the half-life is about 400 years, which means that you're dealing with only a few thousand years before there's no biomaterial left at all, even in something that's very tough, like collagen. Collagen is a very tough, stringy protein. So the very fact that you find the same layer, the same quality of collagen in all of the layers of rock, in every single rock layer that we've found collagen in vertebrate animals, they all have the same level, the same quality of collagen in them, which tells you that it is a one-time event that have produced all of this. So a paper that was published just a couple of months back, actually, a few months back, beginning of this year, which was published by the team that I'm part of in the research area, did their test on an Edmontosaurus dinosaur bone, which is supposed to be about 65 million years old. Okay? Yeah, right towards the end of the dinosaurs. And they found lots of collagen. We have found better quality collagen in this crocodilian vertebra, which is some 120 million years older, supposedly, than that Edmontosaurus dinosaur. That's a lot of years, right? And yet we're finding better quality collagen inside that. In other words, there's a consistent level of collagen quality. You haven't got what you should be getting, which is, and we're doing collagen, what we call collagen degradation tests now, which is where we're testing collagen levels and qualities all the way back through to basically the Carboniferous, some 300 million years old. And you should see, if collagen decays over time, you should see a lovely best fit line that goes, as it gets older, it gets worse and worse quality. We're not seeing that. We're actually finding, it starts off with archaeological, and the older it goes, the worse it becomes, back to Anglo-Saxon and Roman. Then you get to some of the Ice Age stuff, which is technically preserved, and it actually gets a little bit better. Then you get to the really big deposits, what you and I would call flood deposits and stuff, right? And the collagen rises up to almost the same kind of quality as what we're dealing with, slightly older, medieval type bones, right? And so you're getting consistent collagen, and that's all the way down through the geological record, right? From the youngest rocks to the oldest rocks, which tells you that it must be a one-time event. And so that's one of the best ways. So soft tissue research really is doing a lot for challenging the millions of years and also tying back into the idea of a global flood that deposited all of this at the same time and preserved it well all at the same time.
Are the polystyrene trees
Yeah.
in Tennessee similar to the ones that are still living around?
No, they're not, and this is the reason why. So the ones in Tennessee are the same as the ones that are here in the UK. Some of the ones here in the UK. The one that's up at Cragleth Quarry is also a pine tree, which is the Araucaria, right? But the ones that are in Northumberland, that's the one in the Botanic Gardens. The ones that are in Northumberland, the ones that are in the Manchester area, several of the ones that are found around in Wales as well. They are what are known as lycopods. Now, what are lycopods? Well, they're not trees as we think of trees today. In other words, in the sense that they had big root systems, they had a great big trunk, and they had bushy bits at the top. The difference is that the trunk was actually hollow. So it's basically a giant hollow reed with a tree-like mass at the top with big roots. Now, we have lycopods alive today. They're called club mosses, and they sprawl over the ground in the mountains of Snowdonia, right? So in other words, today they're weedy little things. In the past, they were 200 feet tall trees. But then if you know your garden, you might know of mare's tail or horsetail rushes. They're little sort of rush-like tube things, right? They grow to about that kind of height today, maybe, a metre or a metre and a half tall at the most. And they've got little fronds that come off at the side of them, right? That's how big they are today. The ones in the fossil record are identical, but they were 150 feet tall. So they're hollow. The bark, the actual reed part, the part of the trunk of the tree, that turns into coal. The inside gets infilled with a sediment, which is what you're actually looking at. And so the edge of it keeps the impression, but the outside of it turns to coal. So the one up in Manchester, you can still see where the coal was. The ones in Tennessee, it's coal, which is the bark, but it keeps the impression of the fossil actually inside of it.
So they actually lend themselves to the process of rapid.
Yeah, they have to be filled in. And also the other thing is, they had to have been filled in while suspended, because these are hollow. So what happened if they're washed over and buried? Well, they'd be squashed. And some of them are a little bit squashed, but it tells you that they were ripped up and carried along suspended. In other words, they're not stopped and being squashed, and they were being infilled before they settled. Otherwise, they would just squash. They had to be infilled and preserved as they're basically being swept along in water. They can't have just slowly been buried, because they would just be destroyed. So, yeah, that's the lycopod trees, they're called.
How do you define a kind? You started with the idea of things we could think after their kind. Where do you draw the line where a kind is no longer a kind?
Yeah. Okay, a little bit of history. Carl Linnaeus invented our modern-day classification system. Bear in mind, the classification system that he invented is slightly different to today. The term family didn't exist. So he had order and then genus. Now, where did he get his idea of genus from? The answer is straight out of the Bible. Because God created according to their kind. Carl Linnaeus didn't read an English Bible, he read a Latin Bible, the Latin Vulgate. And in the Latin Vulgate, as well as in the Greek, the Septuagint, Greek, the word kind, which is in our English Bible, is genus in both of them, in the Vulgate and in the Septuagint. So genus is obviously, it's a Greek, Greco-Latin type word, and God created according to their genus. So he said, that's great. If God created according to his genus, then I'm going to create a binomial system, which is the basis for my classification system. In other words, everything genus and above in his head was how he was going to organize his book. Right? So all living things go into this. We're going to break them down into major kingdoms. Like plants are clearly different from animals, so we're going to put plants and animals, right? Later on, we added things like, well, fungus don't quite fit in either according to that, so we'll stick them in another one. Then there's bacteria, which is another one, and then there's protozoa. Protozoa is basically the dustbin category. If it doesn't fit in the other four, we lob it into its own category. So it means you get completely different things, which are apparently both in the same kingdom. Anyway, and so basically that kingdom phylum, well, we'll just have creatures that have backbones, we'll put it in one, creatures that don't, we'll put it in another. It's basically how he's going to title his chapters. But in his head, his classification system was binomial nomenclature, which is genus species, right? In other words, kind and a special type of that kind. Because he recognized that there was diversity within a kind, right? Dogs is a classic example that's often used. Cats is another classic example, like you could do it on and on and on. I like using brassicas as an example. Right? Because Brassica olacera is one species, and yet that one species produces broccoli, cauliflower, Brussels sprouts, cabbage, spring greens, kohlrabi, on and on and on. All the kind of cabbagey type things that you see, they're all from one, they're not even one kind, they're one species. And so he recognized there was a huge amount of diversity, so he said, God created according to their genus, so we'll have genus. There's clearly special types within that genus, so we'll have species, right? In other words, a kind fits somewhere between the genus category in our modern classification system and the family, because family was added in. Because once you start viewing classification system not as a classification system, it's nowadays viewed as an evolutionary historical system, because you have one single creature evolving into every of the 5 kingdoms, and it's viewed, you see, Linnaeus was working from the top, basically he was working from, in one sense, the bottom up, right? He said, this is our basis, genus and species. This is how we're just going to add them together. Evolution looks it from the top down. It looks up as one type of creature in the beginning, evolving out into all the different things that we see today. So it's completely the reverse of the way that he invented it. He was a creationist. He believed the Bible. He borrowed from the Bible. So I would say, if you wanted some technical definitions, I would say today, if you can interbreed, not necessarily fertile offspring, but if you can interbreed, you're definitely looking at the same kind. So lion, tiger, same kind, no doubt about it. Now, you have to be careful with that definition because technically, genetically, in fact, we know that, a wolf and a pug are the same kind. They're named the same. They're even the same species, Canis lupus, right? We stick familiaris, which is a racial thing or a variation thing on the end of it to describe our domestic dog, but they're the same species. There is, however, and how can we put this delicately, a biological problem, not aside from genetics, there's a very physical problem. If you were an incompatibility, there's a physical incompatibility if you try and breed a wolf with a pug, right? You're going to end up with a flat pug or a frustrated Great Dane, or possibly both. So you can't, there's a limit. You get to the point where they become so devolved, which a pug in the nicest way possible is a badly degenerate, devolved creature. You get to the point where they're so devolved they can no longer breed with their original kind namesake, if you like, the wolf, right? But dogs are clearly all one kind, right? So you can get some, for instance, the big cats, right, lion and tiger. Cheetah is an anomaly because cheetahs are breeding themselves to extinction. Now, cheetahs can't breed with other big cats, but then they can barely breed with each other because they're literally breeding themselves to extinction. They're in a genetic bottleneck, which means it won't be very long before they go extinct. That's the way that nature happens, right? That's the good to bad to worse. They should be evolving onwards and upwards. They're not. They're breeding themselves to extinction. So if they can breed together, almost certainly the same kind. You can also trace it back again because we know that there was much more diversity in the cat kind in the past. And you can see huge amounts of traits that can come. So I would say you're going to look somewhere between family and genus in our modern classification system. One of the main markers is, can they interbreed with each other? Right?
I was thinking earlier on today, and I know that again, it's the devil's advocate.
Yeah.
Lots of similarities between reptiles and birds.
Yes.
There are lots of similarities.
Yes.
Lots of dissimilarities as well.
Yeah, that's the key thing. See, there are lots of similarities between us and apes.
Yes.
And if you only look at the similarities between us and apes, you can walk away, as many people do, with the assumption that we must be related to the things. What they don't do is look at the differences, right? I mean, there is lots of good evidence now that humans and apes are not 98% similar, but that's the number that was bandied around for a long time, right? There's a lot of evidence. It's now actually closer to about 70-odd percent, 74%, which again sounds like quite a lot, but then we share about 50% with a banana. Yeah. It's all the way that you view it. It tells you that statistics is the brother of all lies next to Satan, because it's the way that you view it, right? So, okay, well, just take that 2% difference. Well, we know that 2% difference is actually over 1 billion different base pairs, right? Now, if you have a code, and that's basically what DNA is, percentages mean nothing unless you know how big that code is. Because if it's a single sentence, that 2% difference can be negligible. But even in a short sentence, that 2% difference can be massive, because you can do this very simple illustration. God is now here. If you delete a space, you have 100% of the code and 100% the same order, but your code now says God is nowhere. Now that's 100% the same code and 100% the same order. You've deleted one space and it's 100% opposite meaning. So there's a huge amount of variety that can be fitted in a tiny, tiny fraction of percentage. And that's quite a large percentage, that deletion, right? But yet, relatively speaking, it's a tiny percent of deletion. It's not even a deletion or an addition of a word. So if you imagine a code that is billions of base pairs long, and that 2% difference is over 1 billion base pairs, which is really over 2 billion bases of genetic code, that's a huge amount of difference between us and apes. So you can do the same with birds, right? If you only look at the similarities, there are similarities in morphology and so on and so forth. We have a whole program on things like feathered dinosaurs. If you see evidence of a feathered dinosaur, you need to ask yourself 2 questions. Number 1, are they feathers? Number 2, are they dinosaurs? And you'll often find that in almost every case of a feathered dinosaur, one of those is a no. Sinosauropteryx is a classic example, clearly a dinosaur, definitely a dinosaur. Are they really feathers? Well, there's no structure of a feather, there's no primary structure of a feather, and they match perfectly with decaying collagen fibres that we see in the world today, which is why it led one of the world's expert evolutionary ornithologists to say Sinosauropteryx is just a dinosaur with decaying feathers, right? And he's an evolutionist. Likewise, beautiful feathers on Caudipteryx, lovely long legs, and a beak. And when it first came out back in, it was about 2010, it first came out, creation research on our fact file, which I recommend people sign up to. It's free, and it kind of shows you we go keep a watching brief on all of the scientific literature and comment on it. You can check this out. Back in 2010, we said Caudipteryx is going to be proved to be a running bird, not a dinosaur. Guess what it's now regarded as? It's a running bird. So it's nice to see that the scientists catch up with us. Because if you start with the Bible, where not only in Genesis does it say that birds are different from dinosaurs, because flying creatures are made on day 5, land creatures, which dinosaurs are by definition, are made on day 6. Even the Apostle Paul makes that point. He says there is one flesh of the birds and one flesh of the beasts. So they're not actually going to be related to each other, right? And so it's often needing to take a step back and not viewing it purely from an evolutionary perspective. So to this day, and I stand by this, and we could spend all night going into it, but I stand by the statement that there have been no such things as feathered dinosaurs ever found, and all so-called feathered dinosaurs either fit into the category of birds that are feathered but are not dinosaurs, or they're not feathers, they're just dinosaurs. And even if there were feathered dinosaurs, it still wouldn't show you evidence of evolution dinosaur to birds, right? And there's a whole load of stuff we could do to talk on that.
Closing on one of David Attenborough's episodes of one of his series, Planet Earth or something, and in the end title, there's a close-up of reptile scales, and then they morph in a feather, and and it's a very powerful image.
Yeah.
The suggestion is, it's evolving into birds, and of course the next episode was to do with birds and all this. But anyway.
So we went to some place that had like casts of dinosaurs. They covered one of them in feathers, and our kids actually, Judah and Bo, they remembered what you said. And they were like, "That's wrong."
Yeah. Well, we had one where it was a very well known replica maker, producer of dinosaur replicas, pride themselves in accuracy. We wanted a velociraptor, life-size velociraptor, because they're only small things. They produced this, and it was covered in feathers, as in the fossil was covered in feathers. And we said, look, as far as we know, there's been no evidence of feathers, not even feathers, no evidence of feathers on any velociraptor. And he said, well, yes, but so many museums were asking us for casts of fossil feathered velociraptors, but we couldn't find any, so we had to put them on ourselves. I just want to show you, just very quickly, on the point of the evolution of the birds, I just want to show you this because I think it's very powerful in sort of explaining exactly what's going on when it comes to these sort of feathered dinosaur things. And we're not even going to get into all the detail of could a creature evolve like this and da-da-da-da. It's just some quotes and some evidence that they show. So this is a statement from the Natural History Museum in London. The gradual evolutionary change, now all evolutionary change has to be gradual, very slowly and gradually, from one thing to the other. You don't have a new wing sprout out. It's got to be very slow and very gradual. The gradual evolutionary change from fast-running, ground-dwelling bipedal theropods, so dinosaurs in other words, to small-winged flying birds, probably started around 160 million years ago. I think I probably used this example when I was here one time before, but it makes a really good point. National Geographic, a few years back. Lovely chart of dinosaurs evolving into birds. And these are all based on supposedly fossil evidence. And they are all real fossils and real birds and stuff that have been found. So you've got over there your Sinosauropteryx at one end, you've got your crow, modern day bird at the other end, you've got all these other creatures that go through it looking lovely. And you would read that and look at the fossils and you would come away from that believing that there's very good evidence that dinosaurs evolved into birds. That's the standard thing. So let's not even question the evolution, let's just add some dates. There's the dates. These are secular evolutionary dates, okay? Remember, this is supposed to be evolving over millions of years from one into the other. So you've got 122 million years at one end, then it's 71 million years, then it goes back to 94 million years, and it goes back to 125 million years, then goes a little bit forward to 124, then all the way back to 159. In other words, the dates are all over the place. These are not successive dates from oldest to youngest. These dates are all over the place. So what we're going to do is we're going to take some arrows and we're going to draw the dates as to where they're supposed to be. We'll put the dates in order from oldest to youngest, okay? So we'll put the dates in order from oldest to youngest and we'll draw arrows as to where they're supposed to be to try and see if we can make some sense. And that's what that looks like. So that doesn't make much. So what we're going to do, we're going to chop out each individual animal, okay? And we're going to order the animal how they actually are according to the ages, right? From oldest to youngest. And that's what that looks like. Now, hang on a minute. The bird, which is Archaeopteryx, which was determined by the Natural History Museum in London to actually be an actual bird because they scanned the internal brain capacity and came to the conclusion that Archaeopteryx has a bird brain. Now, that's an insult to you and me, but to Archaeopteryx, it means that it's definitely not a dinosaur because a bird brain is massively different from a reptile's brain. I mean, bird brains have to cope with flight, it has to cope with gyroscopes, it has to cope with it. It's completely different. The morphology is completely different. Everything about Archaeopteryx's morphology tells it's a bird to the point where even secular scientists agree today it is a bird. And yet the bird is the oldest. In fact, the first bird, according to evolution, which is, even if you want to argue that Archaeopteryx is a half dinosaur, half bird, which, like I said, by secular standards is not even anymore, but back here, the first bird that they presented, which was Euvalavius, is also the second oldest. And one of the youngest is Velociraptor. So even that doesn't make sense according to evolution. And look at the gaps. 26 million years between the first two, then it's only 5 million years, and it's only 1 million years, only 2 million years, then it's 28 million, and on and on. In other words, this is not slow and gradual. Because if you put them in order of actual date, that's what it looks like. You see the big cluster in the middle? This isn't a slow, gradual evolutionary change. This is lots of quick changes in one point of history. And finally, you want to go one step further. There's the statement, the gradual evolutionary change from fast-running, ground-dwelling bipedal theropods to small-winged flying birds probably started around 160 million years ago. Archaeopteryx, which is a fully functioning bird according to secular evolution even today, is dated at 159 million years old, which means, according to their own dates, dinosaurs went from fast-running, ground-dwelling, bipedal, cold-blooded reptiles to warm-blooded, airborne, fully functioning birds in just 1 million years. Bear in mind, it supposedly took apes to turn into humans 7 million years, and we're supposed to be 98% similar to them. And dinosaurs and birds are vastly different based on morphology, based on brain space, based on the fact that one has scales and one has feathers, and even the tiny similarities there are don't really add up, and all of that was supposed to happen in 1 million years. That would take a miracle. And if you really want to break it down, this is just a very brief breakdown of each one of these creatures as to what they actually are. Archaeopteryx had fully formed feathers, capable of flight, had a bird's brain, bird's physiology. It was an unusual bird, but none of what its features are unique to birds. There are birds today that have teeth. In fact, all birds possess a broken genetic code to have teeth. We know there's lots and lots of fossil birds in the past that had teeth, and many birds alive today have claws on their wings. So while it's an unusual bird to have it all together, it's by no means all unique. And even by, like I said, the Natural History Museum standard, it is a modern-day bird. Euvalavius, it had fully formed feathers, capable of advanced flight, had a bird's brain and physiology, so it's a bird. Caudipteryx, I mentioned that earlier, had subfeathers, wasn't capable of flight, but then neither are emus, kiwis, or any other ground-running birds, but it does have a bird physiology, so we said it was going to be a ground-running type bird, and that's what it's agreed to be. Proto-Archaeopteryx, again, ground-running bird, has well-developed veined symmetrical feathers, bird's physiology, hollow bones and the like, but long-running legs. So again, a running bird. Only one has ever been found. Sinosauropteryx has no evidence of feathers. Lots of evidence that they're just decaying collagen fibers due to a warty burial. It's a fully functioning small dinosaur. Annelagea, no evidence of feathers at all. Velociraptor, no evidence of feathers. And Corvus is a crow. In other words, none of those, if you actually break it down and look at it, give you any evidence of dinosaur to bird evolution whatsoever. And so just by that even getting into the could it evolve, couldn't it, you can just deal with the dates themselves don't even line up.
It's Steven Spielberg's fault, let's face it.
Yeah, well, that's this. Yeah. Finish it there?
Just one more.
Oh, yeah. The blossoms, yeah.
The thorns and thistles.
Yeah.
How confident are we that they weren't around before Genesis 3, 17 to 19?
I would be fairly confident, because the first reference to them is only that the earth will bring forth of it as a result of the curse. It follows straight off of, out of the toil and the ground, it will bring forth for you. Also, if you look at it biologically, and this is, I think, really fascinating. If you look at it purely biologically, thorns and thistles are not new creations. They are not something that God had to create a new structure of. They are all the result of degeneration and mutation. So if you have true thorns, you have prickles, and you have spines. True thorns are like blackthorn, hawthorn, which are failed stems. So the plant begins to produce a stem or a leaf structure, and it fails. It is genetically devolved, it's mutated, right, which is the result of something bad. Mutations are not good, they lead going downhill. And so part of the plant is now no longer able to grow and flourish, and so in the end it produces a hard-pointed part, which is what we call a true thorn. Roses do not have thorns, roses have prickles. And there is a difference biologically, because rose thorns are the result of cancer. It is a cancerous structure on the surface of the plant which builds up over time, and it's built in. It's basically genetically, cancer is genetically built into the plant, and so we can try and get rid of that, like thornless blackberries. Thornless blackberries don't taste as nice, in my opinion, as the ones that are in the middle of a big thorn thicket, right? Because they're actually biologically connected, believe it or not, the sweetness of the blackberry and the cancer that's in it, right? So cancer, if you want to argue that thorns rose prickles were there before the curse, then you have to argue that cancer was there before the curse. I think that opens up a lot of problems theologically. And finally, spines, we're talking about thistle spines, cactus spines. They are the result of a plant that has mutated and has shrunk. So you imagine thistle leaves, right? You follow the contour of the leaf and it's got the spike. That spike is actually made out of silica. That silica is the tube of the leaf, which is delivering water to the leaves and taking sap from the leaves back to the stem of the plant. And if the plant mutates and begins to shrink, the tubes stick out, and the tubes are made, so you can see the veins of you can actually trace the thorn down into a vein, right? If you look on the back of the leaf of a thistle, that is basically, as the plant is mutated and shrunk, you're left with part of the plant, the vein that's supposed to be delivering water, sticking up out of the leaf, and that produces the prickle, right? So, or the spine, technically. So every single thorny thing is the result of a mutation, it's the result of a degeneration, and it's the result of something like cancer, mutation, disease, right? Now, I think all of those things have to have come after the flood anyway. Right? And so it's not just a specific reference to thorns and thistles will come because of your sin. It's also a fact that this isn't God creating something new. It's God letting go a bit of his creation. Right? I mean, let's face it, the second law of thermodynamics had to work in the Garden of Eden. Otherwise, you and I wouldn't have been able to eat, or Adam and Eve, rather, wouldn't have been able to eat, right? Biological function, digestion of food, requires the second law of thermodynamics to work. But if the second law of thermodynamics had worked in the same way that it works today, all creatures would have died. All humans would have died. Disease would have eventually come. So God had to be holding it together, which I haven't got a problem with, because Colossians 1:16, all things were made by Christ, for Christ, and they're all held together. They all consist in Christ. But it's a slightly letting go of God. And I think ultimately, if he let go completely, none of us would be able to exist at all. So it's a little bit of a letting go of God to allow his perfect creation to begin to run down good to bad to worse. That would have led to mutations, which would have eventually led to thorns and thistles. Doesn't necessarily mean that they were there on the day that Adam sinned. Maybe not even in Adam's lifetime. But it's that letting go of the world going good to bad to worse, which leads to the flood, which leads to things like major climate change, which leads to partly the diversity we see today, which is partly good, but it's the result of man's sin. And the same with everything else.
Interesting, because most of the old earth arguments are based in Genesis 1.
Yes.
But you've now got these thorns and thistles that are said to be millions of years old, that are clearly after man has been made and sinned, and therefore is a complete kickback against an old earth.
Yeah, I mean, you have cancer in dinosaur bones, Right? So if you want to argue that dinosaurs existed millions of years before man, as many old Earth creationists do, you have to argue that cancer existed before man. And even just by that point, dinosaurs are dead, which means you have to have death, cancer, disease, and thorns and thistles before man, which I would argue, to be as blunt as possible, is a direct contradiction of what the scriptures actually say. Right? And so if you look at, and I'm not lumping old Earth creationists in with the theistic evolutionists, but many of their beliefs about an old Earth are the same, right? And so if you speak to Dennis Alexander, as I did, he's probably the biggest proponent of theistic evolution today. When I asked him, how would you explain what it says in Romans, where it says, by one man sin entered the world and death through sin? He said, our death only refers to spiritual death, not to physical death. And I would argue that is a direct contradiction of the point that Paul is actually making, whereas later on he says the whole universe groans. Well, unless you want to argue that the whole universe has some kind of a spirit, which is neo-paganism nonsense, then you've got a problem if you want to try and argue death and disease and the like in before Adam sinned. I also asked him, when it says that God called his world very good, how do you explain that if you've got death, disease, thorns, thistles? He said, very good doesn't mean very good in the Bible. Very good means fit for purpose. Well, I'm sorry, why didn't God say, and I saw that it was fit for purpose? I mean, heaven's going to be fit for purpose, but it's also going to be good. It's going to be good because God is there, right? So, yeah.
I think they call it eisegesis.
Yeah. So there is a word for it, yeah. Anyway, good stuff. We'll finish it there. Cool.